So now for the big calculation. So we've looked at how to work out the number of moles if we know the volume and concentration, and we've looked at how to find the concentration if we know the number of moles. So what about putting this all together? So say we had hydrochloric acid and sodium hydroxide. So they react together in a neutralization reaction, acid plus alkali giving salt and water. So if we knew that if we had 30 centimetres cubed of 0.2 mole per dm cubed sodium hydroxide, that we needed exactly 25 centimetres cubed of HCl to neutralise it, we could use this information to work out what the concentration of the hydrochloric acid is. Practically, we do this through the titration technique. We put an indicator in there so that we'd know exactly when the reaction had been neutralised, and you carried out a similar reaction back in year 9 when you were making salt solutions from soluble compounds. In terms of our calculations, this is basically just like our 4-step moles calculations we've done before. This is just using our newest method of working out moles to do the mole side of it. Everything else is the same. So just like before, we always started with a balanced equation. Now, when it comes to exam questions, they won't examine you on balanced equations and moles all in one go. So you'll be given the balanced equation, but we're going to do that ourselves. So hydrochloric acid, HCl, reacting with sodium hydroxide, and that is going to give you sodium chloride, our salt, and water. Okay, and that equation is then balanced. It's a nice, easy one there. Now, certainly those of you that I've taught will have been well trained in putting all the information in the question under the balanced equation, and it helps us particularly with these ones where we've got more numbers involved. So the question says, what is the concentration of hydrochloric acid? So we need to find out something about the hydrochloric acid. If 25 centimetres cubed of it, i.e. the hydrochloric acid, so we're going to have 25 centimetres cubed, needed 30 centimetres cubed of 0.2 mole per dm cubed sodium hydroxide. So we've got 30 centimetres cubed of that, and the concentration was 0.2 moles per dm cubed. Now this helps us because we can instantly see, look, we've got the volume and concentration of sodium hydroxide, so we can work out the moles. Then we need to remember what we did before with balanced equations. So once we had the moles of the thing that we knew enough information about, we then needed to use those moles to work out the moles of the thing we needed to know, and we used the ratio. And then once we know the moles of the thing we're interested in, we need to convert those into what is being asked for, so concentration here. So we will have moles in a minute, and we have volume, so we can go to concentration. So our first step is to work out the moles of the sodium hydroxide. Okay, now we've done that plenty of times, so that should be nice and easy. So we go from our key fact, our 0.2 moles per dm cubed, so 0.2 moles in 1,000 centimetres cubed, and we work our way to the 30 centimetres cubed that we are being asked about. Okay, so our concentration told us we had 0.2 moles in 1,000 centimetres cubed. So in 1 centimetre cubed, we've got 0.2 over 1,000. And then what we actually used was 30 centimetres cubed. So 0.2 over 1,000 times by 30. And that is 0.006 moles. Okay, so that is the moles of sodium hydroxide that we've got. So our next step is then our ratio step. So we go and have a look at the balanced equation. We know about sodium hydroxide and we're interested in hydrochloric acid there. Nice and easy one here. So from the balanced equation, for every 1 HCl, we have 1 sodium hydroxide. So we've been kind here. So the ratio is 1 to 1. We know we've got 0.006 moles of the sodium hydroxide, and therefore we'll have the same number of moles of the hydrochloric acid. So obviously some questions you might have a 2 to 1 ratio and so on, and you've got to take account of that. Now, next bit then is to sort out our concentration. So that's what we've been asked about. So I'll just whiz you back up to the top. So with our HCl now, we now know we've got 0.006 moles of this. We know our volume. We pair those together, and then that gets us to concentration. Now, one of the great things about writing all the bits under the equation at the top is it stops you from grabbing the wrong volumes. When you've got all of that stuff written out in the paragraph question, it's very easy to pick the wrong volumes and pair them with the wrong bits. But if you go to the balanced equation where you've written it all methodically, it should help you get the right information. So find the concentration now. So we know that in 25 centimetres cubed of hydrochloric acid that we used in the reaction, we had the 0.06 moles that we've just calculated. So if we had 1 centimetre cubed, we'll have 0.06 over 25 moles. And if we've got 1,000 centimetres cubed, we've got 0.006 over 25 times by 1,000. And that number of moles is 0.24. And then we just need to remember then to quote our concentration with the correct units. So 0.24 moles dm to the minus 3 is your final answer. Now, it's worth for a minute just having a look back over my calculation there. Okay, so we do spend quite a lot of time nagging you guys about annotating your calculations. Now, if you have a look through there, I have written, let me see, 1, 2, 3, 4, 5, 6 words and a scattering of units. Now, that is what I'm talking about when I talk about annotating calculations. I don't want an essay, I don't want loads of explanation, but I do want to be able to see what you're talking about when you've written your numbers down. So a page of numbers is no help at all, particularly if you've made a mistake somewhere near the beginning, because then how do we decipher what you've done with those numbers? But put in the odd bit around, like I have done here, then we can easily see what your intention was, and then you can get error carried forward. So for example, a slip up here by doing something daft up here could mean that you still get 3 out of 4 marks for your calculation, whereas no annotation, just strings of numbers, would mean 0. Okay, so please, please, please lightly annotate your work so we can see what it is that you're calculating at any given time. And actually looking at mine, it would probably be a good idea just to write HCl down at the end. So that was my final concentration of hydrochloric acid. Okay, so again, it's over to you now. So you need to go and carry on working through the PowerPoint where you've got a different worked example, exactly the same stages, but a different worked example to put into your notes. And then it's a case of going and practicing and practicing and practicing. So have a go at the questions. Push yourself. If you're getting stuck, come and use the theory notes. And if you're still completely stuck, then get in touch and we'll give you a hand. Okay.